So my name is Dr. Dibya Bharti. Today I am going to discuss concept of hydropower. This topic is related with the subject energy science and engineering. Subject code is KU033 or KU043, and this is an open elective subject for second year of engineering students in AKTU. So first, what is the introduction about the hydropower? Basically, what we do in we use the energy of water for producing electrical energy. So the energy of water is being used for generation of electrical power using kinetic energy and potential energy of water by motion and position respectively. Okay, so what we do, so water itself is having energy, and we can transform that energy into electrical energy. How? So water can flow. Okay, so it can flow steadily, it can flow with certain motion, and we can speed up that flow of water also. Okay, so as we see the waterfall, okay, so in there is so many force in the water, that is in the waterfall. Okay, so and if we place water at certain height, then there will be potential energy also. So what we do, we utilize the potential energy and kinetic energy of water for producing the electrical power, and this is the concept behind the hydropower. Okay, so hydropower is considered as one of the most economical and non-polluting source of the energy. Since here we will see that there will be no emission of greenhouse gases, so it is a non-polluting source of energy, and it is economical also. Okay, so power generated from water is termed as the hydroelectricity. Okay, that means hydroelectricity means electricity generated by hydropower or from the use of gravitational force of falling or flowing water. Okay, so and this force, suppose there are some constructions by which there are some mechanism by which we provide the potential energy to the water. Okay, so and there in the flowing water there is itself kinetic energy. So both potential and kinetic energy in combined form are being utilized in the hydropower. So potential energy is the energy stored in any object or system because of its position or configuration, though kinetic energy of an object is relative to the moving or stationary object in its intermediate environment, as we can see in this picture. So here see, one person is there at this height, so he or she will be having energy due to this height. Okay, so from the basic of physics we know that the potential energy is mg into h, mass into gravitational constant into height. And suppose here this water is flowing. Okay, so then kinetic energy is there. Okay, so both kinetic energy and potential energy are convertible into each other. We can convert kinetic energy into potential energy, we can convert potential energy into kinetic energy. So this is the schematic diagram for the hydropower plant. Okay, so hydropower means utilizing the water mass flow. Okay, so hydro utilizing the water mass that flow due to the gravity to turn the turbine, and thus turns the coupled generator. So what in hydropower basic concept is that we use the power of water. Okay, we use the energy of water to turn the turbine. Okay, so turbine and generators are coupled together. So once turbine will be rotating, so it will rotate the shaft of the generator. Okay, so when shaft of generator will rotate, there will be EMF. Okay, so the generated electricity, there will be electricity will be generated in the generator, and it will pass through the transformer, and it can be transmitted over the long distance. In this schematic diagram, as we can see here, this is the dam. Okay, so this is the dam. So dam, here we used to store the water, and we can control the amount of water. Okay, so in this dam itself there is intake gate where water flows into the this structure is the penstoke. Okay, so this is the penstoke, this pipeline. Okay, so we can control the flow of water into the penstoke using the intake gate. Okay, so pen stroke carry the water to the turbine. So this is the turbine here. Okay, so this pen stroke will carry the water from dam to the turbine. Okay, so inlet valve when opens, it will let the water flow to the turbine. Okay, so when we will open the inlet valve, the water will flow through the turbine. So water force acting on blades and will turn the turbine. Okay, so water force will turn the blades of the turbine, and okay, so that means turbine will start rotating, and then it will lead to the rotation of the shaft of the generator. Okay, so here these are the high voltage transmission line. So this will carry the electricity to the load center, and from turbine there is coupled generator. Okay, so when the blades of the turbine will rotate, it will rotate the shaft of the generator, and then power will be generated, which will be carried to the load center through this high voltage transmission line. So here water flow, that water which is coming from the dam to the turbine through this pen stroke, it will flow out to the river again. Okay, so there is the returning mechanism also, that the water that comes to the turbine, it will be sent back to the river again. So this is the another diagram where conversion of energy has been shown in case of hydropower plant. So if here water source is in abundance, then the water power is very cheap. But nowadays small hydro and pico hydros are also into picture, because in the rural area where we don't have the transmission wire, and it is hard to lay out the transmission, or you can say it is not economical to lay out the transmission and distribution wires to that remote location. So in that case, the small hydro plant, or you can say the micro and pico hydro plants are there. So those are working as a micro grid over there. Okay, so here see, here in the reservoir water is there. This is the intake gate, and this is the pen stroke area. That this blue line pipeline is the pen stroke area. So here potential energy is there with the water. So when this intake valve is open, so the water from the reservoir will flow to the turbine through this pen stroke. So that means potential energy of water is being converted into the electrical energy in this pen stroke. Okay, so then here this kinetic energy of water will rotate the turbine. That means kinetic energy of water will be converted into the mechanical energy. Then this turbine will rotate the shaft of the generator. Okay, so in the generator there are magnetic fields. Okay, so this mechanical energy of turbine will be converted into the magnetic energy, and then magnetic energy will be converted into the electrical energy. Okay, so though we can say initial investment in hydro plant is high. Okay, the initial investment may be high and operating costs are quite low. Okay, so if we compare it with the thermal plant, so in case of hydro plant operating cost is low and initial investment is high. So we can see how it works. So this is the inside view of the hydro plant. Again there is intake gate is there. Okay, so this is the control gate, and you can say this control gate is also known as the sluice gate. Okay, so reservoir is there. So this is the dam. Okay, so here this is the pen stroke. Okay, so here in the pen stroke area itself there is turbine. Okay, so turbine is coupled with the generator. This is the generator part, and here this is the transformer. Okay, so and you can see clearly in this diagram that the water that is coming from reservoir to the turbine, after rotating the turbine, it will again go to the river area. Okay, so what are the advantages of hydroelectricity? So the first and very most important advantage is that it is most efficient method of power generation. So if we see the efficiency of the hydropower plant, it is more than 80%. Okay, so it is efficient way of utilizing the energy of water, and you can say that it is having the good efficiency. Hydro plants are having good efficiency, and it is usually more than 80%. Okay, so start up in matter of minutes, and it is suitable to serve the peak load. Okay, so during the peak load, we used to balance the load. Okay, so as we all of you know that there is a peak time of utilizing the power. Usually when suppose when all the commercial buildings are in a working mode, okay, or the commercial spaces are open, and industries are working in full flash, okay, all the offices are working. So and this happens usually between 10 a.m. to 4 p.m. So in between this time there is a peak hour. Peak hour means maximum load will be there in the system. So this hydro plant can be started very fast. Okay, so it is used to maintain the peak load. Okay, it is used to serve the peak load. So there are some base load. Base load means the loads which are constant in the system, okay, throughout the day, throughout the year. So those base loads are usually served by the thermal plant, and this peak load are served by the hydro plants. Okay, so this is the convention that were followed. So you can say, so the hydroelectricity or hydro plants can be used to balance the grid, and it can be used to balance the stability of the system, grid system also. Suppose we cannot maintain the peak load, so in that case there will be collapse of the system. So it is used for the grid balancing and stability of the grid. So it is clean renewable source. Okay, so as we see, there is no direct waste and carbon emission. We have seen that there is turbine is rotating only with the energy of water. Okay, so there is no carbon emission, no emission of greenhouse gases. So it is a clean type of energy, clean renewable source is there, and it is environment friendly. So what are the disadvantages of hydroelectricity? So first is that huge amount of civil works required to build dam and powerhouse. Okay, so it require huge amount of civil work, like we need to create the dam with this concrete structure. So this is the first disadvantage. Second one is, that's why the capital cost is high. Second one is that the unpredicted water output, unpredicted power output in several places due to the weather and season. Since water in the river are weather dependent and season dependent. Okay, so there may be unpredicted power output. Okay, suppose in the rainy season there is more water in the river, then power output may be more, and in the summertime power output may be less. So it is unpredicted type of source of power, electrical power. So and third is that the turbines which are there into the water, which are placed in the middle of the water, so those produces sound, very noisy sound and vibrations in the water. So these turbines are life threatening for the fishes. So they disturb the aquatic life. So runoff, what is a runoff? So part of the water cycle that flows over land as surface water instead of being absorbed into the groundwater or evaporating, that is called as the runoff. Okay, so the part, we can say the part of the precipitation, snow melt or irrigation water that appear in uncontrolled surface, stream, river and drains. Okay, those are the runoff. Okay, so as we know, so water are absorbed in the ground. Okay, but some of the water that flows over the land or the surface, so those are not absorbed into the groundwater, or they are not evaporated. So those are the runoff water. So storage and pondage, so the collection of water in reservoir upstream of the plant and increasing the capacity of stream for a long period of time is called the storage. Okay, so these are the parts of the hydro plant. So storage plants work as base load station. Okay, so base load station means the hydro plants which will be used for serving the base load. So base load plants, obviously base load plant should be of the high capacity and takes the land on the base portion of the land curved. So peak load plants are designed for taking care of peak loads. So this is the pondage. So for a short period of time, the pondage increases the stream capacity behind the dam near the plant. Okay, so near the behind the dam there is pondage also. So for short period of time, suppose due to the in the rainy season water is more, so we can store the water in the pondage. So and that water stored in the pondage can be used when there is less water in the dam. So pond permits to store the water during the off peak hour, and this could be used during the peak hours on the same day. So if this is if there is considerable distance between the plant and the reservoir, pond is needed at the plant to regulate the flow. So important factor is that, like wind power plant, for hydropower plant also site selection is an important factor, and there are some factors which should be given careful consideration while we select the site for the hydroelectric power plant. So first is the water availability. The estimates of average quantity of water available should be prepared on the basis of actual measurements of a stream or river flow. So the river flow data should be based on daily, weekly, monthly and yearly flow over a number of years. Okay, so the plant capacity and the estimated output as well as the need for the storage will be governed by the average flow. So the primary or dependable power which is available at all times when energy is needed will depend upon the minimum flow. Okay, so water availability is the important factor while we select the site for the hydropower plant. Second is the water storage. So the output of hydropower plant is not uniform due to wide variations of rainfall, and to have uniform power output, a water storage is needed so that excess flow at certain times may be stored to make it available at the times of low flow. To select the site of dam, careful study should be made of the geology and topography of the catchment area to see if the natural foundations could be found to put the best use. Okay, so if natural catchment area is available, so that is the best site to select the site for the dam. So third one is the head of water. So the level of water in the reservoir for a proposed plant should always be within the limits throughout the year. So distance from the load center is also important. Most of the time the electric power generated in a hydropower plant has to be used some considerable distance from the site of the plant. To be economical on transmission of electric power, the routes and the distances should be carefully considered, since the cost of erection of transmission line and their maintenance will depend on the route selected. Okay, so there should not be more distance from the load center. Okay, so because it will add up the extra cost. So this is the picture which shows the site before construction of dam, and this is the picture after construction of dam. So what has been done here? So a dam has been created in between the two-sided mountain. Okay, so here this is the natural wall has been there, and a dam structure has been created in between the river. So fifth one is the point is the access to site. It is always a desirable factor to have a good access to the site of the plant. So this factor is very important if electric power generated to be utilized at or near the plant site. Okay, so the transport facility must also be given due consideration. Okay, so suppose there is some fault or some part of the plant is to be replaced, suppose transformer need maintenance. Okay, so the plant should be connected with the transportation mode. Okay, so this is also important considerable point. So sixth one is the type of the land site. The land to be selected should be cheap and rocky. Okay, so the land should have largest catchment area to store the water at high head and will be economical in construction. So the rock should be strong to withstand the stresses transmitted in the dam structure as well as the thrust of the water when the reservoir is full. Okay, so the rock should remain stable in all the condition. So see, we cannot form the hydro plant over the Ganga river in India, because Ganga is there in the land near the river Ganga is not rocky. Okay, so that's why usually these hydro plants are there in the hilly areas. Okay, so because they also provide the largest catchment area in between the mountains, and they land over there is the rocky, okay, so that they can withstand the thrust of the water, okay, when reservoir is full. So hydropower plant uses the potential energy of the water, potential energy of water stored in a reservoir to operate turbines. So the turbines are connected to large generators and can operate on varying volumes of water to adapt to changing demand for electricity. Hydroelectric power plant capacity is related to the height and capacity of a reservoir and requires certain conditions in local geography in addition to a water source. Hydro is a renewable energy source and most cost efficient than many other renewable source of energy such as photovoltaic. So hydro power currently provides about 25% of the world's electricity and is very flexible in scale. So commercial installation range from 1 megawatt up to the largest installation till date, that is 18,400 megawatt in China. So this is the types of the hydro plant. So large hydros are there which is having more than 100 megawatt capacity. Medium hydros capacity is 15 to 100 megawatt. Small hydro is having capacity 1 to 15 megawatt. Mini hydros are there with capacity 100 kilowatt to 1 megawatt. Micro hydros are there 5 kilowatt to 100 kilowatt, and pico hydros are also there, so which is having capacity from a few hundred watts to 5 kilowatt. So this is the these are the essential feature for the water power plant here in this schematic diagram. So this is the catchment area, this is the reservoir dam, this is the sluice gate, this is the penstoke, inlet valve is there, after inlet valve turbine is there, draft tube and tail race is there, and in here turbine is connected with the alternator. So the essential feature of water power plant or hydro power plant are catchment area, reservoir, dam, inlet waterway or spillways, conduits, surge tank, prime movers, tail race or out waterway, and powerhouse. Tail race is the portion which sends the water that comes from a penstoke to this turbine to the river again. So that portion is the tail race. So this is the flow sheet of the hydroelectric power plant. Okay, so here this is the diagram that previously has been shown, that has been elaborated here. So this is the reservoir area, this is dam. Behind the reservoir there must be catchment area. So sluice gate is there. After sluice gate to the inlet valve, there is this portion is known as the penstoke. This is the inlet valve, turbine, alternator, and tail race. So essential feature of the hydropower plants, that the catchment area of hydropower plant is the whole area behind the dam, and it drains the stream or a river across which dam has been built at the suitable place. Okay. Second one is the reservoir. So whole of the water available from the catchment area is collected in a reservoir behind the dam. The purpose of the storing of water is in the reservoir is to get a uniform power output throughout the year. So a reservoir can be either natural or artificial. So a natural reservoir is a lake in high mountains, and an artificial reservoir is made by constituting the dam across the river. Okay, so if natural reservoir is not available in the site, then at some places artificial reservoirs are made. So a dam is a construction, a dam is built across the river for two functions: to impound the river water for storage and to create the head of water. To give the potential energy to the water, we create the dam. So dams may be classified according to their structural limit, like timber, steel, earth, rock field and masonry. So these, so and according to the height also. Okay, so these are the spillways. When the water enters the reservoir basins, the level of water rises. So and to relieve the excess water, a structure is provided into the body of dam that is called as the spillways. Okay, so this basically this spillways is the safeguard structure for controlling the water. So conduits, so this is the channel which leads water to turbine. Basically conduits means penstoke. So it is a channel which leads water to turbine, and a tail race is a channel which conducts water from the wheel. So conduits may be open or closed. Okay, so open conduits are canal or flumes, and closed conduits may be pipeline or tunnels. So surge tank is there in the penstoke. So basically it is a small reservoir. Surge tank is important part in the hydro plant. So it is a small reservoir or tank in which water level rises or falls and reduces the pressure swing, so that they cannot be they are not transmitted in full to the closed circuit. Okay, so this surge tank is there to control the pressure in the penstoke, you can say. So prime movers are there. The prime movers converts the energy of water into mechanical energy and further into electrical energy. So they are classified into impulse and reaction turbines. Then draft tubes are there. So the draft tube serves two purposes. It allows the turbine to be set above tail water level without loss of head, and it regains by a diffuser action. The majority of kinetic energy will be delivered in this manner in draft tube. So powerhouse will be there. So the powerhouse is the building in which the turbine, alternator and auxiliary plants are housed. So this is the simple surge tank. A surge tank is a vertical standpipe connected to the penstoke. So surge tank are built high so that water cannot overflow that structure, and the water surge tank always placed on ground level above the penstoke line. And you can see this the height of the penstoke surge tank is greater than the height of the dam. So the surge tank always placed on the ground surface above the penstoke line at the point where the you can see where the pressure changes. At that point we construct the surge tank. The height of the tank should be increased with the help of the support. So based on the different category, these are the types of the hydro plants based on the available head. Three types of hydro plants are there: high head plants, medium head plants and the low head plants. So greater than 300 meter height, it is high head plant. 30 to 300 meter, it is medium head, and less than 30 meter, it is low head plant. Based on the nature of load, there are two types of hydro plants: base load plant and peak load plant. Based on the quantity of available water, okay, so runoff rivers plants are there, storage plants are there, pumped storage plants are there, mini and micro hydel plants are there. So this is the structure of the high head plant. Okay, so here you can see this is the tunnel. Okay, so this is the surge chamber is there, this is the penstoke, powerhouse is there, and after reservoir this is the head work. Okay, so this is the structure for the high head plant. And this is the again here after reservoir high head works is there and surge chamber is over there. Okay, so see, this is the medium head plant. Here inlet sluice gate is there. Okay, so here dam is there and sluice gates are here. Okay, so here this is the draft tube and penstoke is there. Okay, so this is the medium head plant and this is the low head plant. This is the structure for the low head plant. So what are the base load plants? So plants supplying base load which is generally constant and runs without stop. Okay, the loads base load plants are those which are constantly running. Okay, so those are the base load plants, and they should have the greater capacity because some constant loads are there in the system which are not going to shut. Okay, so the runoff river and storage type power plants are used to serve the base load plant. So peak load plants are there. So these plants supply power at the peak load time when load is more than the average load. So when runoff river plants with pondage and pumped storage plants are used as the peak load plant. They store water during off-peak time and used to supply the peak hour. Okay, so the load factor is low compared to the base load plant. So this is the runoff river plant. So pondage refers to the collection of water behind the dam and increases the capacity, steam capacity for short periods. So this plant has flexibility to meet the hourly demand, hence the discharge is more and 3 to 8 times. So pondage increases the steam capacity for short period. Okay, so this is the storage type plant. So these plant would have reservoirs of large size to facilitate the storage of water, and thus it is independent of seasonal streams. Okay, so the majority of hydro plants in the world are of storage type plant because the plant can be used to serve the both types of base load and the peak load. Okay, so that's why. So this is the pump storage plant. So this is like peaking. Pumped storage is a method to keeping water in reserve for peak period demand, and pumped storage is a water pump to storage pool above the power plant at the time when customer demand for energy is low, such as during the middle of the night. So water is allowed back to the turbine generator at the times when demand is high and heavy load is there on the system. So this is the structure for the pumped storage plant. Okay, so these are the advantages of the pumped storage plant. It is used as peak load power supply only. It is more economical, and it is used as the to control the load frequency in the system. It is having low capital cost. It is pollution free, and load on hydro plant is uniform always. See, we have seen the hydropower today. So there are many advantages of the hydro plant, and apart from this there are disadvantages also. So if you see the scene of the Uttarakhand, there are landslides, and there are common human life is being disturbed due to some of the hydro project plant. Okay, so we can say this is a clean energy. This is safe. This is not harming the environment, but in fact it is harming the human life, or you can say it is harming the aquatic life also. So you cannot always say that it is safe, but yes, from if you see from the aspect of thermal power plant, it is somehow better. Okay, but question is that we need to be conscious while we select the site for the power plant, because the site selection should be considered in such a manner that there should not be harm to any life. Okay, that may be aquatic life, that may be animal life, or that may be human life. Okay, thank you. This was all about the today's lecture. Thank you all.